we continue. And after this interesting talk from Professor Peter Voss, we can have another talk from a practitioner, from a person who is quite famous in Java world. Mario Fusco is an official Java champion, and some years ago he joined Red Hat and quickly became a project lead for very popular rule engine known as Drools. And now it's part of IBM. Probably Mario can share some what is the current situations over there. People are certainly interested. But today, Mario, from his practical view of a very experienced software developer and developer of very popular decision intelligence tool will bring his perspective to machine learning, symbolic reasoning, how it works together with latest achievement in AI. Mario, looking forward to your presentation.
Okay, thanks a lot, Tiago. So yes, I'm Mario Fusco. I'm the project lead of Drus, which is the uh, rule engine of Red Hat and also IBM now. Actually, we are in the process of transitioning Drus to the Apache Foundation. It's going to be a quite long process, to be honest, a little longer than I expected, but we should be almost be there. So I believe we will have the first release of Druze inside the Apache Foundation umbrella in like let's say 2 or 3 weeks. Okay. Anyway, this talk, of course, will speak about symbolic reasoning and rule engines and rules in particular. But my effort was to put together these technologies, which is considered uh, good old-fashioned AI with some more modern, let's say. Okay, so the idea is to try to leverage machine learning as symbolic reasoning and take the best of the two worlds. So uh, why are not doing machine learning only and just give up with symbolic reasoning? Because well, machine learning is a tool, but like any other tool, it has its shortcoming, and it's not a perfect tool for everything. And it's basically on statistical reasoning, and sometimes statistic. Well, it's not perfect, you know. Meaning that yeah, this is something that happened to me quite recently. I bought a washing machine on Amazon, and then Amazon started suggesting me to buy 3 more washing machine just in case uh, 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 I'm founding a laundry. I don't know, but of course it's because these 3 or 4 products are all statistically related, and so Amazon is keeping suggesting me all of them. Okay, so this is what it happens when you apply blindly pure statistics. But if you think about it, it will be quite easy to mix this stuff with symbolic reasoning, right? And uh, if you think about the specific domain model, it's quite clear that if a user bought a washing machine recently, it's the lesser probably thing that we will buy in the next few weeks and months. So it's something that you shouldn't really suggest, but it's something that probably you cannot discover under a statistical point of view. Is something that is part of your business domain. So why not using the knowledge of your business domain to avoid this kind of business mistakes? Okay, and yeah, this is the quite common thing, something that I heard very often, and the reason why I added this slide is to well, I believe that for all of you the difference is clear, but you know, artificial intelligence and machine learning are always using very often used as a synonym. They are used as swappable terms. You use artificial intelligence or machine learning exactly with the same meaning, and of course they don't have the same meaning. One are a subset of the other. So artificial intelligence is something it's only something that is supposed to mimic the human behavior, and this can be done in many ways. This can be done, of course, with machine learning, but it can be also done with a rule engine, which is not machine learning, but also has the uh, role of mimicking in some way the behavior of a human, and more importantly of knowledge aspect of the specific domain. Okay, and if you think about it, it's all about fancy naming. If I call my software rule engine, it sounds something from the 80s, something old. It's not that really interesting, and probably I could call it production system. Now I started it calling symbolic artificial intelligence, and it suddenly become cool again. Okay, but it's really about giving the right definition to things. And once again, why you don't want to use machine learning alone nowadays? Why you may want to integrate machine learning with symbolic reasoning? Because if you think about it, uh, with a rule engine, with symbolic reasoning, you can really encode the knowledge of your domain. Okay, so in the washing machine example, you can say people generally do not buy three washing machines in a row, and this is something that you can encode in your domain knowledge. Okay, it's part of your business, and it's a bit stupid if you try a machine learning algorithm to discover something that you already know, to discover something that is really part of your core business. Probably you can just encode the the business rule with a proper programming language of declarative language with a rule engine or whatever, and use the machine learning for the pure statistical part. Okay, so this is the idea: mixing these two technology, leveraging the advantages of both. And this is a quite common, well, not common. It's an active, let's say, area of research, which is in general, it has a few names. It's called hybrid artificial intelligence, or even neurosymbolic artificial intelligence. And there are a few patterns to combine symbolic reasoning and artificial intelligence. As you can see, the name is a bit fancy. What I will show in my demo today, it's an example of the very last pattern in this list. But as you can see, there are many ways how people are experimenting in mixing symbolic reasoning and artificial intelligence and machine learning in reality. And okay, the idea of my demo started from news that I read a few months ago. I don't know if you heard about it, but in essence, what happened is that Air Canada had, I believe, they dismissed it, this chatbot made with an LLM that was supposed to help customer also for the refund policy, for ask refunds for specific situation, and then this chatbot was chatting with a customer, and at some point they totally made up out of nowhere a refund policy that really isn't an Air Canada thing. I mean, it's something that doesn't exist in Air Canada, but in essence, this chatbot told to this customer that he could be entitled to receive a refund of 650 Canadian dollars. Okay, so of course, the customer applies for the refund. Of course, Air Canada said, okay, this is not really something that is in our refund policy. We don't know anything about this. And this customer went in front of a judge with the screenshot of the chat. And guess what? Air Canada was obliged to give the refund, even if it was not really due, but just because the LLM totally made up the refund policy. Okay, and this is a quite typical hallucination, and in reality, uh, we cannot get rid of this kind of hallucination. It's again, everything is based on statistic, and statistic can statistically produce the right result, but in some cases it can go terribly wrong, as in this case. Okay, so uh, hallucinated output is something that you cannot get rid of, and uh, there are a few patterns to uh, let's say not totally resolve the problem, because probably it's a problem that is impossible to solve in general, but to mitigate the problem. And to mitigate this problem, the two main idea is using more than one language model, and have a way to have one LLM that control the others, or a voting system or stuff like this, or combining this deep learning algorithm with something more well established like symbolic reasoning. Okay, and yes, you don't want really something that can hallucinate to really decide about your business domain. And I'm telling this because actually there are mathematical proof that hallucination isn't avoidable. It's something that is structurally present in an LLM, in how it works, and you cannot get rid of it, at least not totally. Okay, and and I believe more in general, these there are a few general problem of using machine learning algorithm for everything, also when they should be used. The first one, of course, is accountability. I mean, who is responsible for a decision, a wrong decision taken by a machine learning algorithm? Can be the creator of the model, the service provider, the final user. I mean, if you, I don't know, if you use automatic driving and you have an accident, who is the responsible for the accident? The owner of the car, the manufacturer of the car, the creator of the machine learning algorithm? It's really hard to know, and it's not a solved problem. And I believe that yeah, I really appreciated the former talk. I don't know if you are so close to AGI. Uh, I'm not that positive, but maybe I'm wrong. I'm not a data scientist. Uh, it scares me a bit, to be honest. Um, I see a lots of opportunities, but also a few problems. And the main problem is that we machines should be held accountable for this kind of things, for mission critical stuff. For uh, when the life of a person is in question or in trouble, well, machine learning are not accountable, so they shouldn't have the last word. That's my point of view in general. Okay, and then the other problem is the lack of transparency. Okay, machine learning, the algorithm took a decision, but why? And you are also under again a legal point of view, often obliged to be transparent, often obliged to give an explanation. I mean, if a bank refused to give you the mortgage you asked, the bank cannot just tell you, we cannot give you the mortgage because the machine learning algorithm say no. Okay, it's not an explanation. It's not a transparent decision. You need to give a better explanation. Okay, and you cannot find this explanation, for instance, just looking at the weight of of the neural network, at the internals of the neural network. This is like you know, slicing a brain and trying to figure out what the person was thinking by looking at the slices. I mean, it's not, it doesn't work this way, of course, and you really need to be transparent in this kind of decision. And this third thing is probably the most interesting, the one that makes me think a lot. The fact is that if you think about it, when a system hallucinates, you cannot really say that this is a malfunctioning. You cannot really say that the system is not behaving as correctly or not behaving as it has been designed, because an LLM can hallucinate by design. Okay, so it's not like a software bug. Okay, so when you have a software bug, I don't know, you in some point of an algorithm, you use the plus sign when you it should be a minus instead. Then it is a bug, and then you can fix the bug. But when an LLM misbehave, it cannot be treated as a bug. It's not something that you can go into the code and fix. And it's also not something that it's even questionable if can be classified as a malfunctioning, because again, this is really in the nature of how statistically algorithms work. They can hallucinate, they can produce wrong result, but it's hard to say if it is a bug or not. And anyway, it's not something that you can fix. Okay, so yeah, as I said, one of the idea is fixing this hallucination, this LLM hallucination by using another LLM. And when I heard about this, I think of an old joke of 20 years ago that when they said, okay, if XML doesn't solve a problem, it's like violence. It's because you are not using enough of it, right? And this remembers me that thing. And of course, well, it's something that you can try, but it's a little bit odd to me. Okay, so my idea was instead again to mix machine learning and rules in my case, and the symbolic reasoning and a rule engine. And I started from that use case from the Air Canada chatbot and try to do something similar. And I used the rules in a twofold way for this demo, for this example. One, of course, is to calculate the amount of a refund in case you are really entitled to have it. And the second is that I used rule to implement machine learning. So what this chatbot does is collecting the data of the customer. So you are in a state, in the first state, you are collecting the data of the customer. And then, of course, you have to collect the data of the flight. And then the interaction that you need with the LLM will be different. The LLM now is interested to extract the flight data from your chat, so it will ask different questions. And then you will finally enter in a third state when you have all the necessary information, and then you can calculate the refund in a precise way using rules. So let's see how this works. Sorry. Okay, so I have this these uh, yeah, very simple chatbot. I will start saying hi, and yeah, you can notice two things now. Well, first of all, that I'm not that good to create user interfaces. I'm a backend developer, so it's not very nice to see. And yeah, the other thing is that this demo is very slow because I'm running everything on my machine. I'm running the web server on my machine, but most important, and this is the most consuming part, I'm running the LLM on my machine. Okay. Anyway, it's starting responding. It tells me that now remember that the state machine that I mentioned before. Now the system is in that first state. It's trying to gather the information about me, about the customer. So it's asking me basically for my name and my age. Okay, so let's try to say that just my name is Mario Fusco. Okay, and yeah, while this thing is taking some time to reply, let me show you what's going on. First of all, let me show you the rule that I'm using for the state machine. I have all the data gathered in this object that is called session data, and then I have a state that is made of three possible states. As I said, I'm now in this first state where I'm extracting the customer data, and then when the customer data will be completed, but I still don't have a flight, I will transition in this second state where I will try to extract the flight. And when I will finally have both, I will try to calculate the proper refund. Okay. So now it's telling me, I don't know if you can read it. Let me try to make this big. Okay. Anyway, he's telling me, okay, nice to meet you, Mario Fusco, and but please tell me your age. Okay, what's happening here? It's happening that the LLM is still in the first state because it needs my name and my age to do a proper calculation of the refund. I only provided my name, so the data of the customer are still not complete, and the state machine is still in the first state, still asking for my age. Okay, so I will say that I'm 70. Okay. Uh, and what's happening now? It's happening that the system finally should be able to extract both my name and my age. So the extra customer state should be ended, and we should transition in this extra flight um, state. While these data are important, probably I didn't mention this um, because I have this chat service, and in the this with this Quarkus integration, I'm instructing the LLM to say, okay, your goal is asking the data about the customer, and then when I transition to the extract flight state, then I also transition to a different state of the LLM. So I will change the role of the LLM, and now the LLM will be no longer interesting to collect the customer data, but it will be collecting the flight data. And then, of course, the LLM it's happy with my customer data, as I said, and then it is asking for the number of my. It's in the second state where it's extracting the flight data, and it's asking for the flight number and which kind of trouble I had on this flight. So, for instance, I can say I was on flight 22, and it had a delay of 4 hours. Okay. So what should happen here? Now the data are complete. I have both the data about the customer and the data about the flight. So I should. So this means that the session data now is populated with both the customer and the flight. I should transition to this third state, and in this third state, the data are used again by another rule to determine the refund. Okay, so this rule is saying that I'm eligible for the refund if the delay in minutes was more than 1 hour, and the amount of the refund is the number of minutes of delay by 2, multiplied by 2. And if I'm a senior, I'm older than 65, then I should have a 10% more. So this is my domain knowledge, right? This is the rules, the refund policy of my company, and I encoded this with proper rule. I'm not letting the LLM to hallucinate on it to invent stuff. Okay, so now it should have produced a result, and it's telling me that I should have a refund of $528, right? Why? Because I said I had a delay of 4 hours, which are 240 minutes. Multiplied by 2 is 480. And since I told him that I'm 70, it means that it's 480 plus the 10%, which is 528. Okay, so it is really applying the data. It is a nice chatbot. It is using the power of on LLM to do a friendly collection of my data on one side, but on the other side is applying the business rule in the proper way, in the way of how my business work, to decide what is my refund. Is there any question about this? Or maybe I can go to the end of the presentation. Okay, this is the demo. If in case if you want to give it a look and try it on your own. This is a screenshot of a former run because you know, with LLM you never know if things can go wrong, and so this is my plan B actually. And in reality, yeah, I also try to ask to ChatGPT. I believe there are a few possibility to mix an LLM with a rule engine. Can you list me? Can you tell me what do you think about it? What are the possibility for mixing these two technologies? And it replies with a nice list of things that you can do. So the very first one is the one that I showed you. It's the customer support chatbot, but you can use this kind of mixed technology for quite a few things, like personalized e-commerce and sales. Smart home automation is very interesting in my opinion, but yeah, and as I say, financial services and loan approval in the same way. If you have to approve or not a loan, you don't want the LLM to decide. You just want the LLM to collect the data, but at some point you want to apply the business rule of the bank, of course. So this is one first idea where we started experimenting to mix rule engine and machine learning. The second idea, this is admittedly a little bit more experimental, but in my point of view, what a rule engine does is that you feed the rule engine with your business rule and with some data, and you produce answers. And if you think about it, the machine learning does something different. You provide it normally with the data, and in this case, the answer for the data provided. Okay, and then the machine learning, what the machine learning does is extracting rules. These rules is not often in a human understandable way, meaning that the rules are the weight of the neural network typically, but there are ways to make, there are algorithms to make this rule human readable, to translate the rule statistically discovered by the machine learning into some something that a human can understand. So I believe we can create this loop using machine learning to discover rules from data and answer, and then we can use these discovered rules in our application to properly apply these rules discovered by the machine learning algorithm, but this time in a more controlled and, more important, in a more transparent way. Okay, so in this way you can mix, you can really reach hybrid reasoning, hybrid artificial intelligence, having the advantages of both worlds. As I said, the machine learning is nice because it's highly adaptable and flexible, and can handle complexity, and can find pattern when there apparently there isn't one. So it's much more flexible again, yes, but it has the main problem is the lack of transparency. While the rule engine is has the advantage of being totally transparent. If when it produces a decision, you can have a straightforward way to figure out why that decision has been taken. But the disadvantages are the lack of generalization, and the fact that you need to encode the rule in a programmatic way instead of having an automatic way of collecting the rule. Okay, so the idea is to mixing these two possibility here, and again trying to generate, in my case, the rules from some data. Okay, so we experimented with this. Again, this is in a very early stages, but I wanted to introduce it to this approach. One algorithm that we are used is called the 1R algorithm, meaning that from a set of data, it generates a rule that fits the biggest part of the data, and then it generates one more rule, so it refines an existing rules. I mean, it goes on and on by generating more rule or adjusting the existing rule in a way that makes the data to fit the output that is eventually produced by the rule itself. Okay, so I have an example here. We started from a data set for diabetes prediction, and there are lots of features, lots of variables in this database, but we want to keep the thing easier. So we took the first three variables. I mean, the three variables that demonstrated the highest relationship with the possibility of diabetes diagnosis. So we used these three features to generate rules. So we started starting from the data, and then our one algorithm generate a set of rules, and then with the former iteration, it refines rules by adding more condition and so on. Okay, so this is another possibility. Again, this is quite a little bit more experimental, but I see some opportunities in this area as well. Okay. And to conclude, okay, I want to again make clear that machine learning is it's only a fraction of the whole artificial intelligence ecosystem. We are trying to mimicking the human behavior in a way that can be uh, um, encoded, clearly encoded or not, or meaning, I mean, using a real engine or a neural network. And the very bottom line is that I believe that machine learning is not a replacement for a symbolic reasoning. I believe that they are two very complementary technologies. They are strengths in different areas. So if you need to cover both this area, which is quite common, probably you need an hybrid AI system like the one I demonstrated with my very simple demo, because in this way you can really mix the flexibility and the human friendliness of a machine learning algorithm, of an LLM, for instance, with the strictness and transparency that you need to apply your own very business rule, the rule that drive your business really. And this is what I have.
Okay. Thank you, Maria. And questions, please.
Any question on this? I'm curious of the feedback. I mean, is there anybody who is experimenting something similar in a similar area? Because
Yes.
I again, I believe they are two very related technology. Hi, Dennis.
Hi, Mario. How you doing today? Thank you for your presentation. I think it goes along with a lot of the people here are thinking and have been experimenting. I was wondering, your selection of the 1R algorithm, what made you pick that particular algorithm over many other algorithms that exist for the same purpose?
It's the simplest thing. I mean, the idea was to start experimenting in this area. I'm not. I mean, this requires also a bit more of statistical knowledge, which is not really my area. So actually, there is a colleague of mine who is working in this area. She's called Nicole Princess, which is the girl who prepared this presentation with me. So uh, I know there are a few algorithms in this area. I don't know if you are experimenting with something similar. The 1R is really the most simple one, and you can track the progress because again it works in an incrementally way. You know, it generates a rule, and you can figure out why. And if it's not what you expect, then you stop it at the very first iteration and try to figure out what's going wrong, and then it generates a second rule and you try to understand the improvement of apply both rules instead only of the first one, and so on. So we basically wanted to try the idea, put the idea at work, and wanted to select one algorithm, and just selected the simplest one for us. That's all. Not very, yeah. That's all. Not so much thoughts about it. But if you are experimenting in a similar area and you are using different algorithm, I will be very curious to know your experience on that area.
Certainly on the group here, there's a lot of people that have been experimenting in
Indeed,
that. They have
I believe so. Yeah.
different recommendation for you, but I just wanted to know if there was a particular motivation behind it. Thank you very much. That's great. Great work.
Thanks.
Okay, we have Ratina.
Yeah. Hey everyone. Thank you, Mario, for the wonderful session. It was really helpful and very insight. Gives a good understanding about the models and the comparisons that you are working with. So we are also in our form like having a similar kind of IoT, like where we are using the business data or domain related data using the machine learning models and then feeding it to a role engine, right? Like, but and this, one of the common questions that we used to get from the architecture, right? Like, so these data can be fed directly to the ruling system. Why do we need to go this to a machine learning model and then fed it to a rule system? So, say suppose like in our example, like whatever you demo, right? Like we are getting the age, we are getting the date of the travel, etc. Right? Like so that can be directly fed to the rule engine system, right? I agree. I know like this is all domain data, but to answer to the architects, people who are unaware, like how do we solve this out? The common
So
question that I'm getting.
let me recap. You are wondering while we are using an LLM for this particular domain for the chatbot, right? I mean, you can encode everything with a rule engine. Is this a question or?
Yes,
Yeah.
yes.
So again, if you look at the iteration of my, let me share this again. If you look at this kind of iteration, I don't know if you can read, but it's something nearly impossible that you can achieve in this form. I mean, you cannot do this only with a rule engine. You can collect the data in a form, in a fixed form, and extract the data from here and use the rule engine, and then you don't need the LLM. Yes, that's true. But if you look at the iteration between me, the potential customer, and the chatbot, it seems almost human, right? It's very friendly. I mean, this is how I would like to interact with a chatbot, and it's not only for this. I mean, there are a lots of new technology. For instance, what I do quite often this time is using reg to chat with my own documentation or with the documentation of a project. So what I do is take all documentation of something that I want to learn. I make the machine learning algorithm to the reg to digest all this documentation, and then instead of having to read all of them, I chat with the chatbot that has ingested all of it, like it was a person that it is knowledgeable of that field. So it's a different kind of iteration. I mean, it's a more human-friendly kind of iteration. We starting seeing also in that experimenting with replacing graphical user interface that are rigid, that are form that you have to fill with this sort of iteration. So in essence, we are replacing the user interfaces with this kind of interaction, which is something nice, I believe. I don't know if you agree, but I like to put
I
my
agree. I
insert
agree.
my data system in this way. Yes.
Yeah.
Okay, Rimantas.
Thank you.
Rimantas has a question. Rimantas, just unmute yourself.
Yeah.
Okay.
Okay.
You can talk. We don't hear you, Rimantas.
You can write maybe.
Oh, you have mic issues. Okay. Do we have more questions? Okay, Rimantas, you can type your question if you want in the chat, and we can answer right now. Or...
Yeah, yeah.
Okay, let's see. He's typing. Okay, he wanted to ask if you had any challenges with negative scenarios when using LLMs for chatbot scenario.
I of course I did. Yes, I mean, as I said, this is probably the third time that I do this presentation, and the very first time the LLM wasn't working as expected, so it wasn't able to collect my personal data from the chat, and the demo didn't work, and I had to show the screenshot. So yes, it may not work. What is happening in particular in that iteration is that the way I'm instructing the LLM is to say, extract the data of a customer from this chat, from the text of the chat, and return me the data in the JSON format, in pure JSON format, so I can parse the JSON format and produce a Java object with the data from the JSON string. But what happens from time to time is that the system hallucinates, and it produces the JSON string, but not only that, together with the JSON string, we put some content in the string, or after the string say, I collected this data because I found, and it gives you some fancy explanation that you really don't need. But this breaks, of course, the JSON parser, and the system blows up. So from time to time, it doesn't really follow the instructions. So yes, it's not a 100% reliable system.
Okay.
Yes.
Okay, Maria, thank you very much for practical view of blending LLMs and machine learning and our traditional rule engines. And we can get more questions during the session, during our panel. I just want to note that you will see similar AI assistants, LLM-based assistant today. It would be presented by Tom Debevoise and Denis Gagné. And I want also to wish you a successful migration of Drools to Apache Foundation.
Yeah.
That's a great news.
We need it. Yeah.
And good luck. Thank you very much.
Thanks. Okay. Thank you, Jakob. Bye.